In this video, we are going to talk about Newton's third law of motion and gravitation. Newton's third law of motion and gravitation. Okay, so consider some object having mass m1 kg and some another object having mass m2 kg, and both are separated by some distance cr. Then the gravitational force acting between these two objects according to Newton's law is given by F is equal to G into m1 into m2 upon r square. This is in accordance with Newton's law of gravitation. I have derived this in one of my videos, in one of my previous videos. So if you don't know how we came to this formula, you better check out my previous videos. Okay. So this is the force of gravitation, and this is the force with which mass m1 attracts mass m2, and this is the force with which mass m2 attracts mass m1. Basically, both of them attracts each other by equal force F. Okay, the same thing holds true for Earth and some other object also. Let us say this is Earth. This is Earth, and there is some person or a boy standing over here. He threw a ball in upward direction. He threw a ball in upward direction at a height h from the surface of the Earth. So he threw a ball in upward direction at a height h from the surface of the Earth. And what would happen is the ball would move downwards, that is towards the center of the Earth, towards the center of the Earth. Now, so one can say that Earth exerts force F on the ball, and it is given by G into m or mass of Earth into mass of ball upon distance. Here is radius, small r is the radius of the Earth plus capital H, so with it is r plus h the whole square, that is distance between ball and the Earth. So this will be the force of attraction that Earth will exert on the ball. But the same force this ball should also attract, this ball should also exert on the Earth. What I mean to say is, just like Earth attracts a ball, the ball should also attract the Earth. As we discussed in this case, mass m1 attracts mass m2, and mass m2 attracts mass m1. Just like that, Earth would attract ball, and ball will attract Earth. So, reasonably speaking, just like ball moves downwards, Earth should also move upwards. That is, it should also get accelerated. Just like ball comes down, Earth should also move up. But this does not happen in practice. Why? Let us understand this. See, Newton's third law of motion states that every object exerts equal and opposite force when some other object exerts force on it. And that's why Earth would also That's why that ball would also exert some force on the earth. And still earth does not move and ball always moves. That is, whatever we throw upwards would move downwards, but earth would never get lifted. So why? Okay, the fundamental lies in the equation F is into equal to m into a, where m is mass and a is acceleration. Therefore acceleration is F upon m. So what we see is, for given force, acceleration is inversely proportional to the mass. That is, if F remains constant, because if this is earth and this is a ball, then the magnitude of force acting between these two would be F for both of them. So this remains constant for both of them, and so acceleration is inversely proportional to the mass. So if the object for which mass is small, acceleration would be big. So obviously for ball, mass is going to be less. Mass of ball is going to be very less as compared to mass of earth. Hence we cannot see the effect of force of attraction from this ball on the earth. But yes, as mass of earth is very big, we can see the effect of force F on this ball, and so we denote this acceleration A by G, which is acceleration due to gravity. G is equal to 9.98 meter per second square. Well, again, G is a kind of acceleration, so unit is going to be same as that of unit of acceleration, and its value is 9.98 on the surface of the earth, and we can safely consider it as 9.98 above the surface of the earth up to the height of 10 kilometers, because the variation in the value of G is very less, and we can assume it safely as 9.98 for all practical purposes. So that's the reason why always ball moves towards earth and earth never moves towards ball. Let us have some brief recap about this. So Newton's third law of motion and gravitation. We considered two masses, m1 and m2, and we know that both of them would attract each other. Remember, both of them would attract each other by force F is equal to G into m1 into m2 upon r square. Now this force is mutual force, so m1 would attract m2 and m2 would attract m1. So same thing would takes place in case of earth and ball, or earth and any damn object. But so technically speaking, just like earth attracts a ball, ball also attracts the earth by equal and opposite force, according to Newton's third law of motion. But this thing really does not happen. Earth remains stationary and ball comes down. Why? That is because force is equal to mass into acceleration. Acceleration is equal to force upon mass. For given force F, that is constant value, because for this ball and this earth, the gravitational force acting between them will remain constant. So acceleration is inversely proportional to mass. So if mass is small, acceleration would be big, really big. And when we compare mass of earth and mass of some object, say ball, then mass of ball is indeed going to be very small as compared to mass of earth. So this value for ball would be very small, and hence acceleration would be very large. And hence it is seen that ball always move towards earth and not the other way. And we call this acceleration as acceleration due to gravity, or gravitational acceleration, and its value is 9.98 meter per second square. That's it in this video. Thank you.